Hello, everyone. We're doing a special video today. At SVIC, we just released the State of Webhook report, and we're just going to go through, kind of do a quick overview of some of the findings, and have Tom kind of explain a little bit what he thought of it, because most of this was written by me. So some of the things I think are going to even be surprising for Tom.
Yeah, I mean, I already took a look at the report and I found like quite a few things surprising. And it's funny because I look at our stats a few times a day. I'm very much aware. I talk to our customers, but still, yeah, you found some like really interesting data there.
Yeah, so I guess like really quickly, I should talk about how we generated the report, which is I started off with somebody else's like list of 100 best API companies. Um, that way, I wanted to kind of avoid picking the companies ourselves because then it kind of skews your numbers, right? It's like a bias to the companies that you pick.
Yeah.
Um, and then basically, I just read all of their API docs to see, do they do webhooks? What type of best practices do they implement? Things like that. The only time I like substituted companies in was when the company somehow they're a top 100 API company, but they don't even have public API docs. So if I didn't have public API docs, I replaced them on the list, just because I couldn't. There's nothing for me to read.
Yeah, I mean, it makes sense. There are like a few companies, that kind of like have this like partner on the API.
Yeah.
So even though they power a lot of the web's infrastructure, a lot of companies, they don't actually have anything that you and I can see.
Mm-hmm. So kind of like the structure that we took is we kind of broke it down, the things that we're analyzing, into a few different sections. So one is like, what does their implementation look like? And then what does their documentation look like? Because it's really important that you document your webhooks well. Because if you don't, it can kind of be a crapshoot sometimes when your users are trying to implement themselves. And then on the delivery end, that's where we actually looked at Svix's internal data to get a feel for how do webhooks actually behave in practice.
Hmm.
So those are kind of like the three main sections of data that we put out. The
Okay, enough for the
intro is like,
teasing. Let's get cracking. I'm
all right, all
curious to
right,
see
all right.
everything.
Here's the
Yeah.
stats. So obviously the most basic one is like how many actually had webhooks at all. And we found that to be 83%. So 83 out of the 100 that we analyzed had some sort of mention of, we have webhooks that you can subscribe to.
Yeah,
Um,
I think it's kind of like something just to like weigh in on this one as well.
yeah.
Webhooks are everywhere. Webhooks are super useful. They're being asked by customers all the time. Yeah, but I think as you show in like the next few pages, having webhooks, is kind of like really depends on how how you define the required level of quality.
Right.
Because like just ticking that box sometimes not enough to get like the full value out of really having them. So
Yeah. And I would say even this number is probably like higher than if you took like the average of like all API implementations, right? Because these
yeah,
are technically, it's like kind of like the cream of the crop, so to speak, of API providers.
yeah.
Um, but it shows like, the best are implementing this. So yeah. So the next thing we looked at on the implementation side is do they offer automatic retries? Um, and we found only about 67% do automatic retries. And this is even like they just said that they do automatic retries. And so I believe them. I think I put in here, yeah, there's like some of them that are like, hey, we do automatic retries, but then they don't really give you any any details about it either. I took their
Mhm.
word for it. And then we have like a little breakdown here of on average how many retries do they offer, right? So do they retry once, twice, three times? I think this is pretty useful for some of the in practice stuff that we're going to share down the line in terms of
Yeah.
like how often do retries succeed and fail and things like that as well. So it's a kind of a good combo of information.
Yeah. I think also it kind of like relates or slightly relates to what you're talking earlier with your intro about documentation, which
Mhm.
is, like an API in its essence is a contract. And this is what you just described as like a contract with a lot of like redacted areas that it's really impossible to know what you're agreeing to. So like, okay, are you gonna retry? Like how often? Once, twice, five times? Like how do I know? Like, can I rely on this? Like all of those missing dots are like really just make the contract impossible to like rely on.
Yeah, and I even saw like there was a huge discrepancy from like one service to another on what exactly they told you about the retry. So you would think it'd be like, okay, we do retries. This is how many times we retry. Here's the schedule. And like there are like maybe like three or four things that you would expect to see, and there's just
Yeah.
like a huge variation of like which of those things are actually laid out in the documentation. So some of them are like we retry 5 times, but they don't tell you the schedule,
Yeah.
right? Or like some of them even say things like we retry a bunch of times in 24 hours on an exponential back off schedule. They don't tell you how many times and what what the actual
Yeah.
schedule is. So there, yeah, it was interesting. There was like a huge variation between how people even just document their retries, whether they do it or not, and then how they
Yeah.
do it.
I remember when we started, we kind of like we ticked like all those keywords like, hey, exponential back off within like X days and whatever. And then we realized that we're really trying to kind of like, how do you call it, like how do you call it when you kind of like do a linear regression? We kind of like do like trying to do with our language like a linear regression over like our or exponential regression, whatever like you want to do, like, but like over our retry schedule. And then realize, it would be much easier just to, like, copy paste the actual retry schedule, actually the actual delays,
Yeah.
and just put them like super explicitly. And yeah, they're like kind of like mostly exponential back off, like mostly that, and it's like within that time frame. But they're only like 10 retries. You can just like list them all. So I think that's like a really simple quality of life, and also just much easier to describe. Just like really copy the numbers. So yeah.
And it's also, I think, the most useful for your users, right?
Yeah,
Like that
exactly.
they know exactly what's happening.
Yeah, exactly. So
So
yeah,
we
less
found
confusion.
like most providers are doing like 3 to 10 retries,
Hmm.
and then a few do like a lot, like more than 20. Um,
Yeah, I think the ones that do more than 20 are the ones. I mean, I'm guessing again. You saw the data, but like the ones that just don't have exponential back off. So they're kind of like, oh, we retry every minute for like 24 hours or something like
hmm.
that.
That would have been a good
Yeah,
breakdown for me to add. I did a few like cross examinations to see if there's what do you call a correlation between like different features.
yeah,
Um, and now I'm curious. I'm going to go back and look at my data to see if there's a correlation there. The other thing I did notice also, I think the ones that offer like a lot of retries are the ones where it's like we need to make sure it goes through like 100% almost, right?
yeah.
Like or as much as possible.
No, 100% makes sense. But like especially if you go with exponential like back
Yeah,
off,
yeah,
like 2 to the power, or whatever to the power of 20 is like a very large number. Almost
yeah.
doesn't
That's
matter
true.
what the base is. So really,
We will retry in 1 year.
yeah, exactly. Every minute for a year, and then you know, yeah,
All right.
limited
Yeah.
value.
So like I think we talked a little bit about the exponential back off and why that's valuable, right?
Yeah,
Maybe Tom, like really quickly, give an overview of exponential back off.
yeah. I mean, so the idea here, and again, like we use exponential backoff as like a terminology like quite loosely. Essentially, what it means that you just go on an exponential, scale. So like you wait a second, 2 seconds, 4 seconds, whatever, 8 seconds. We don't actually really follow that, but we do something close to that. And the idea there is to, first of all, like give people time to recover, and B, to kind of like avoid the clustering that gets if you like retry every minute. And so like if you have to retry every minute, and then like the other ones are failing, and then like all of a sudden you still get like all of this like extra load. And if you kind of like keep on spacing that, you potentially like once things are fixed, it's gonna like space out a bit better. But also really just like give people time to fix the issue without like continuously hammering the service while waiting for that. Because like I mean, if it failed every minute for the last like 60 minutes, I think it's like pretty likely it's gonna fail in like minute
Yeah.
61. And I think also like the time sensitive like aspect of it, like if it arrives like minute 61 or minute 80, it's kind of like it's less of a concern. So it's okay to kind of like lay off the server, like stop hammering it for a second and kind of like
Right.
back off for a bit. Yeah.
Yeah. So this one, it wasn't adopted nearly as often. Only 25 of the providers had an exponential backoff schedule. A lot of them were just linear, like you're saying.
Yeah.
Um, and obviously, like if they only doing like one retry, you can't really do an exponential backoff off one.
Yeah.
Um, so yeah,
But
most
I
of
think,
the exponential backoff ones, I think, like you're saying, were the ones that were doing somewhere in the range of like 5 to 10.
yeah,
And then the
uh,
last thing
you
that
know,
we added here is manual retries. So that's like literally something failed and you want to click a button to retry one
yeah.
specific message. That I think actually was the least implemented feature. Or
You
do you
know,
just think it's good best
yeah,
practice?
this is like one of those funny ones, right? I mean, in a sense, like, like it's machines that are talking here. Like, why do you need like manual human intervention, right? You don't. Like, manual retries make no sense. But it just so happens that like the people writing the code are humans, and they're gonna mess it up, and they're not gonna, like they're just gonna like want to deploy the fix and see if it, it's kind of like first of all see if it fixes things, like really just like check themselves, but also if they're sure that it's fixed, they kind of like want to update the record, right? They want to like ingest the
Right.
webhook already, like they don't want to wait for the next retry in 5 hours because a customer is complaining about something is broke, being broken. So it's both the least useful thing and the most useful thing you can have, because like you really, under normal circumstances, it should never be used, but
Hmm.
you really feel the lack of it when you need it. So
Right.
I was saddened to see this number. That's essentially like the short version of what I just said.
Yeah, and I think this correlated pretty heavily with like logging as well, because usually what happens is you have some sort of like log, right, of all
Yeah,
the webhooks that you've done, and then you can like add some UI in where you can like click a button to retry. That's generally the pattern that we see of how those two are implemented. I think it's not like completely one to one in that way. Sometimes the manual retry is just like they have a specific API endpoint for retrying the failed message. Um, and then
yeah,
sometimes the logging, it just doesn't have that feature. But those two together, I think, were the two lowest best practices that we recommend
yeah.
that weren't really implemented.
And I get that. It's kind of like what you just said, which is in order to do the manual retries, which is super useful, you need the logging, because otherwise, what are you going to retry,
Yeah.
right? And so it makes sense that they're correlated. And as for logging, it can be a pain in the ass to do,
Mhm.
because it almost surely means you need to persist things to a database, make it queryable, like indexable, like all of that, so you can read it out and like show it to a customer and build the UI for all of that. So it makes the webhook system a much larger lift.
Right.
But I think the problem, which is kind of like what we touched upon a moment ago with like the manual retries, is that, or even before that, is that it's a contract, and I want to make sure that the other side kind of like fulfills their end of the contract, and I want to see when they don't, so I can take precautions. I can, well, not precautions, but I can like recover from like those areas, and I can see what's going on. I can debug, which is one thing that we've seen with like customers that have switched from their own webhook system to ours, is that they get so much value out of the logging, because all of a sudden, first of all, their customer support teams have all the tools that they need in order to
Right.
access this information, kind of support their customers. But even a step before that, their customers have all of that data, so they can really easily see the reason why something failed, know that it's their fault, know how to fix it, and then do the manual retry to fix it. All of that without involving, without putting undue load on the webhook provider, like on one of our customers. So, and this number I get, like I see why it's so low, but again, it's such a pain not having it. So I'm
Yeah, it
saddened
does
by
make the
it.
developer experience a lot better when you have both of those things together, the logging with the manual retries. Like when you're trying to debug something, you just want to kind of fire one off to see if it's working now so that you think you
Yeah,
fixed it. Yeah.
and I think like another thing, which is the retries, like the idea behind it, which you touched on, is like some people really want to make sure that webhooks get sent, and I get them, right. That, like if you rely on that, and like for example, GitHub sends webhooks to trigger CI, and if those webhooks are not triggered, CI is not triggered, and then everything is like funny, or maybe like a deployment doesn't happen, and all of those kind of things. You really want to make sure that things are reliable, and without having any visibility into the failures, which is essentially like what login is. Like, how do you even know if the retry schedule like kind of like works, or how do you know if like especially with no retries, like how do you know that things are operating correctly, and if they're not, like what's going on? So there's just like so many aspects, like why it's kind of like it's like tiny paper cuts that together just like bleed the whole animal to death kind of thing.
Yeah.
Sorry for the grim turn. Yeah.
Yeah. So like I think this is actually the bright spot, I think, in the research is event types. Now I think this makes sense why this one is so popular. So 93% implemented event types. I think the only implementations that didn't have event types were basically the ones that only had one event type that you can subscribe to anyway. Like that was like the
Yeah.
only event they had that was important or that their users would even want to subscribe to, and so they didn't bother implementing an event type. I think generally speaking, because I mean this is like the bulk of the value, right? Like these are the events that your users actually want to see, so it makes sense that people have kind of implemented the event types.
Yeah, I mean, you know, in a way, right? And I see, I think like Datadog does it, but like there's surely other implementations. Um, you know, you can just send all of the events, right? Like, I mean, you don't need to have any such concept on your end. The problem with that is that all of a sudden you're sending like 1,000x the webhooks that your customers want to receive, and especially if you kind of like let them define multiple endpoints, you can be sending like thousands of irrelevant webhooks to like one destination, and then like when you only want one a day, you get like 20,000 a day. So like it really having that as a top level construct that your customers can like really like filter by is such an important thing when you're really doing things at scale.
Yeah.
Yeah.
So the next important section is on message authentication. This one I think is actually pretty important. Obviously, you need to secure your webhooks, and one that I was expecting a higher adoption of. I mean, I guess technically people have adopted message authentication pretty widely. So, like, I think there's only like 15 that didn't have any authentication at all. But you can see like it's pretty spread across the different methods.
Yeah, I
I
mean,
mean, a decent amount of HMAC because that's I think what is considered best practice. We consider that best practice, and a lot of people implement it that way. There were a lot of these like 10 people do just basic, and that's the only one they do. And then a lot of people also it's just like, hey, here's the secret, and we pass it directly in the header kind of thing.
yeah, they're like, as we can see even just like in this graph, like there are like many different ways of doing this. I would argue some are better than other. And yeah, I mean that's why I kind of like really just like want to recommend doing the right thing. um I think like just like even today, was it yesterday? Yesterday you shared a link with me about like a new CVE or like in Home Assistant about like the lack of like webhook authentication, because what they were doing, they were relying on source IP for like authentication, which is, by the way, terrible idea in general, like for security in general, not even like webhooks related. But essentially what happened, they had like a misconfigured proxy there, which made it look like everything was coming from localhost. So nothing was. I mean, again, I briefly looked at like the CVE, like I didn't have a lot of time, but like made it look that everything came from localhost, and then kind of like nothing was authenticated. But it's so hard to to check because like we have the test suite is like running a local, like all of that. Just, I mean, assuming they had a test suite even, but yeah, I would highly discourage like makeshift authentication methods. No, so essentially like the most popular one is like HMAC SHA-256, and like HMAC is like a cryptographic construct that essentially protects you from like extension attacks and like a few other things. It just like makes the underlying hashing more secure. So choosing SHA-256 is probably not a good idea. SHA-1 is considered broken. Again, in practice, it's probably not the end of the world, but still, like it's considered broken. Like you should not be using like broken cryptography. So really, like if you'd go in with like signature, HMAC 256 is probably the best bet. And then there's kind of like JWT, JWS. The problem with those is that first of all, you base 64. First of all, you force a structure. Two, you base 64 the JSON, which kind of like makes it a bit more annoying. It's just like a lot of overhead, and then just like more complexity. So really, just I don't think that's a good idea either. And then there comes kind of like the basic auth, secret header, bird token, which are essentially the same thing. So like basic auth is like very similar to what like Slack and Discord do, but you can see what's going on there, where like so many people are spamming Slack and Discord because people are not used to having like secret URLs. And also there is a potential for like leaking that for like in a variety of ways. So like really just not a good idea. So like really, if you're doing that, do HMAC with SHA-256. That's the golden standard. Like everyone does that.
Yeah, and I saw even like a few services have like multiple versions of their signatures, so you can tell kind of like the path that they went through. It's like, okay, like this isn't version 1, they only do basic auth, and like version 3 now we support this HMAC signature thing. and they
Yeah.
have like you have to version it. Yeah.
Yeah, I mean, I think, like we actually at Spix, we also support versioning our signatures in case like SHA-256 ever gets, like cracked or broken or weakened.
Hmm.
Um, but yeah, I hope we never need to change. Like, I think, yeah,
Yeah.
hopefully this is going to be good enough for a while.
All right. So the next section we looked at is the documentation, how people actually document their webhooks. Again, because it's Fix, we take the documentation so seriously. It's part, we consider it part of the product. We thought we'd evaluate the actual documentation itself in terms of how much information it's providing. Like, we have a few things that we really like seeing, like code samples, right? I think that's kind of across the board with documentation in general, not just with webhooks.
Yeah.
But there were a lot of webhook specific documentation that didn't have the code samples, right? And I think you can see here there's like a huge correlation between whether people were offering the HMAC signatures and whether they wrote the code samples or not, because I think that is the obvious thing that you'd want to give people some code sample for is how do you actually verify those signatures?
Yeah, I think even this graph is like slightly biased because I'm sure, like, I think like when you collected the data, we did code sample as like a checkbox, but
Mhm.
even code sample is like a gradient, right? Do you provide
Yeah.
just a code sample for just JavaScript, or do you have code samples for like 10 languages, or do you even have an SDK that automatically does the verification for you, so you don't even need a code? Like, I mean, you can have the code sample as well, but like you also have like the SDK variant. So like really here there's a gradient as well. And I'm
Yes.
sure that if we, if there was a way to graphically, represent all of that, we would have been like, it would have looked even more dire.
Yeah, I can tell you for sure the SDK that has like a webhook verify function, that would, if I included that as its own thing, that would be the most rare best practice
Yeah,
feature for
no, I'm
sure.
sure.
I think it would probably be less than five had that in my research.
Yeah,
Um,
I mean, just a quick self plug. We are the way we do like signature verification is actually like fully open source and like an open spec, and we have open source libraries for verifying and signing, so anyone can just like take them and like do best practices and get an SDK for free. So you'd have to be silly not to do that. Just
yeah,
just saying. And because like as we mentioned, like a lot of these companies, they version their the signatures. They can just switch.
yeah, yeah. Let's see. Yes. So the next thing that we really like seeing is test like instructions on how to test. Um, this also is pretty rare. You can see here only 35% actually offered any guidance on how to test endpoints, and there's like this also has like a huge gradient in terms of how much information there is. So like some people are kind of just like, oh, here's here's how to go to Postman and send yourself a test endpoint to see if, or test message to see if the endpoint's working, right?
Mhm.
Or the one that we saw a lot is here's how to test on localhost using ngrok. That's very popular as well. Um, but then there's also things that we really like seeing, which is like sending test messages. It's kind of similar to the manual retries, but this is like, it's not even a failed message. It's like literally just like a templated test message that you can click a
Yep.
button and fire off so that like you don't actually have to go into your app and try and trigger an actual event.
Yeah. No, I think that's again, it's one of those things that really just like doesn't make any sense, right? Like, why would you need that? But then again, everyone uses that, so it's kind of like, yeah, just like make sure to have a way for people to like send a message that they can check that actually gets there, they actually verify it. I mean, I think, and you kind of like mentioned that. So you think if like you're a payment provider, so what do I need to do now? I need to take out my credit card, order a fake a fake product on my website. Like, what is the right way to trigger an event and really kind of like have to trigger a test event is like such an easy way of doing that,
Yeah.
both in testing, but even in production, just like when you first make it kind of like live, just like test that path once to make sure that everything works. I think like so valuable.
And I think actually, like there was one actually like really impressive example of testing docs. I think it was GitHub. Like they even had like a test suite that you can like
Mm, yeah,
paste, like where you're doing automatic testing on your webbook system. I thought that was pretty impressive.
I think Stripe
That
has
was
it
the
as
only
well.
one I
Maybe
saw.
I'm misremembering. Oh no,
Oh,
yeah,
really?
okay. I thought, yeah, I thought Stripe had it as well, but maybe I'm misremembering.
Yeah.
Yeah,
Um,
no, but I think like one thing about testing as well is that we value it so much, and we created like Display a while back, which is like a way to help you test local webhooks, also a way to just like send webhooks to a specific destination that you can like view everything that's going on. But we also added like an API component to it, so you can really you can test like multiple scenarios and see like how they behave. Yeah.
Yeah.
So just we value it a lot.
All right. So this is the next section. This was, I think, the section that I like learned the most from, which is interesting because it's our own data essentially,
Yeah.
right? How often do webhooks fail? How often do they succeed? And then like how like useful are the retries? I think this is really informative for people because these types of numbers you don't actually see anywhere else.
Yeah.
Um, so for us at Swix, the success rate of deliveries is like almost 96%. And I think like on the face of it, that looks like a big number. And so you're like, oh, why do I need to retry stuff if most of them are succeeding? But then if you kind of look at it the other way, it's like, well, actually, that means like 4% are failing. That's kind of a lot to fail
Yeah.
consistently, especially if it's something mission critical, right? Like you were mentioning with payments.
Yeah. So 1 in 25 payments doesn't register. That's
Yeah, I
what.
don't think you want
Yeah.
that. I think you want all your
Yeah.
payments.
Yeah. Yeah.
um, so that was like the
I think
first interesting data point, I think.
now I think also like just one thing about this number as well. It's I'm willing to bet that this number is actually higher than what you'd see in the wild. And we do a lot of things to make sure that delivery works well at Swix. I mean, first of all, we let people know all the time like when things don't work. So when things stop working, people can fix that effectively and easily and quickly.
Mhm.
Otherwise, it would have maybe just like lingered for multiple days, and then like the failures would go up. But also we do stuff like like rate limiting the delivery
Mhm.
from us to like customers. So like our customers can like limit the rate in which they receive messages. And so that effectively means that they can avoid being overloaded by like a stream of just like a torrent of messages like under in peak times, which is again another reason for failures, which is server is overloaded, etc. So I'm willing to bet. I mean, I think flipping how we look at it, like the way you just did, like 4% is like a massive number. It doesn't feel like 95 feels like a good good
Right.
grade at school, but like no, 4% is a massive number. But I think in practice the numbers are even higher outside of
Yeah.
Swix.
Yeah.
So
And I guess I should clarify this is the success rate on that first initial delivery attempt. It doesn't count
yeah,
retry. So now let's kind of get into some of the retry numbers. So what this graph is showing is the success rate of the retries for our retry schedule. So you see it, it says 5 seconds, 5 minutes. That's when the retry is being sent after the previous attempt, right?
mhm.
And so for me, the most interesting part of this was that actually the second retry is the one that succeeds the most.
Yeah,
So I would have expected the first one succeeds the most, and it kind of just like dwindles down the more you go because you've tried more times. Um, but I think the interesting thing about this is that the timing really matters as well, and I think that's why the exponential back off really matters.
yeah. I think like if it's always bad to like explain data after the fact with not having an hypothesis before. I know it's bad science, but just to like weigh in with like why I think it's going on. I think there's like a peak or like some sort of load over a period of like 20 seconds or something, and then when it retries within that first 5 seconds, it actually within that period of load. So it's still failing. It's still like unable to like process all the events. The database is under load, whatever. But when you wait 5 minutes, you don't have kind of like this overlaying of the new messages and the retries at the same time hitting that server, so they kind of like have that buffer. And I think that probably helps. And actually, one thing that I forgot to mention that we do at Spix that I think really helps is we add some jitter. So we don't really retry after 5 seconds. We retry after 5 seconds plus minus like 1 second. We don't really retry after 5 minutes. We retry after 5 minutes plus minus 10 seconds or 15 seconds.
Mm-hmm.
And so really the idea there is that if you had like a burst of like 1,000 in a second, and that's too much for one of your customers, now they're going to get it over a period of 20 seconds. And that, yeah. And I think the longer we wait, the biggest the jitter, because the jitter is like 10% or 15%. I don't remember the exact number. I mean, capped at a certain number. I don't remember the exact numbers, but I think that helps a lot.
Yeah, I think the jitter specific, like I was looking for it a little bit in the documentation, but that's not something that gets documented that often. Just because it's like a real, it's more like a nice to have implementation, like on our
Yeah,
end,
it's
where it's like
implementation
kind of
detail kind of thing. Yeah,
behind the curtains, kind of.
yeah. Do we even do it? Do we even document it? I don't know.
I think we do, but not
Okay.
like we don't explain it. We just kind of say that we do it.
Okay,
Um,
not like front and center, 15% each
right?
direction,
No,
whatever. Yeah,
we don't have that. We
yeah,
could. I think it would be helpful for them to know that it's like thoughtful. But
yeah,
it would really more be kind of like marketing in a way, like hey, like that than actually like helpful. Like there's no like action item that the users can
yeah.
take based on the jitter. So
And I think that's maybe why we haven't documented it, right? Because
right.
we try to be extremely concise and
Mhm.
actionable for our customers, and not just like flood them with like
Yeah.
useless information.
I mean, I think I saw a couple people mention jitter, but I didn't see anybody actually say like how much they jitter. Like I don't think
Yeah,
that's almost getting into the weeds too much.
yeah, makes
Uh,
sense.
and then on average, it took like 2.5 retries for the retries to succeed. Like of the ones that failed that initial attempt and ended up succeeding at some point off of retries, on average was about 2.5. I think that goes to show like the most people implementing 3 to 10 is probably a pretty good number.
Yeah,
So this one is a breakdown of the messages that ended up failing and what status code that they returned. I think no matter what you do, um, messages are going to fail, right? At some
yep,
point. And I think also the 1.4 number here is, I think on the previous page, it was like 4.2% failed that initial message. Love that, 1.4% end up exhausting the retry schedule and like just the endpoint is broken, right? So that's about
yeah,
like a third of the initial failures. It's just like a broken endpoint.
yeah. I mean, I think like what's interesting in one sense, like I looked at this graph and I found like extremely interesting because like wow, so many 4 4s. But then actually, like when I dug deeper and like tried to understand like what's going on, I realized that like HTTP status codes are used differently by different people. So,
Yeah.
for example, if you get a webhook and that webhook references username Ken, and user Ken deleted his account, so the receiver, the consumer of the webhook, would not be able to like load Ken, like the user Ken. They would return a 4 4 potentially, right? So it's not. It doesn't necessarily mean the path was wrong and not found. Like like the webhook receiver was deleted from the server. It could just be like an entity was not found, which by the way can be temporary. So if they have eventual consistency and it hasn't really fully created on their side yet, and then like when you retry, then it doesn't fall for. It just like it's really magic. Like looking, I think at like the stats there, like seeing that a 4 4 can become like 503 can become a 4 4, then can become like a 204 or whatever. So
Yeah, I think the interesting part of this for me was the zero status code.
yeah,
Initially, I saw, I was like, "What is that?" Right, and when I asked James, who pulled the data for us, he said this is mostly timeouts
yeah.
or DNS lookup failures, is what he was saying.
Yeah, I mean, I think so. Just to like elaborate further, it's like everything. So we denote zero to everything that's not an HTTP
Mhm.
error. So it could be connection reset by peer. It could be like DNS failure. It could be connection timed out. It could be like many things. Um, yeah, it's just it makes sense, right? I mean, the internet is kind of like is a scary place, and like packets disappear, get kidnapped and disappear all the time. So you know, it's not surprising, but also it is surprising.
Mhm.
Um,
It's a pretty low number though, 2.2% the timeout, and like timeouts are like only like a portion of that. So
yeah, I mean, I think also if you can go back for a second, like
right,
I think the timeouts are also so if you look at like 503 or 502, that's somewhere that's kind of like I'm blanking on my HTTP status code, but like one is like gateway timeout, one is like gateway unavailable, whatever. I never remember which is which, like 503 or 502. But that is also a timeout in a sense. It's kind of like the server is overloaded; they're unable to respond.
okay,
And yeah, and 500 can be like, I mean, well, whatever. It's it really is hard to know from the status code exactly what went wrong. But like all the 500s are probably like either database load, maybe coding error, and like just timeouts, just like timeouts due to load.
Okay.
Very common.
Yeah. So the next thing we looked at, in line with those timeouts is like how long does it take to actually get a response, right? Because one of the practices that a lot of people do is, there is like a timeout limit of X number of seconds that you have to respond within, or else they're gonna fail the message, right? So that they don't have to just like wait forever for you to respond.
Yeah.
So I think, yeah, this is pretty interesting too. Like P95, 622 milliseconds. So that's still less than a second. But I think when we were looking at it a little bit more granularly, we were looking at most of the timeout policies from the APIs we looked at were around 3 to 5 seconds was the most common. I mean, there were some that went down to like 1 second and things like that. At Spix, we do 15. I think you kind of see why we put it pretty high. Like, we don't really want to fail message just because of the timing. And I think if we would have set it at like one of these more common, like 3 second, 2 second, like our failure rates actually would increase by a lot just from having more timeouts.
Yeah. And I fully get why people put whatever values that they do. It puts loads on our system, right? Like we have to keep many connections open for like long periods of time. But as you said, it's a trade-off, and we'd rather be on the webhook succeeded side of the line than like the one that just like more efficient for us. Mm-hmm. And we take a lot of like hits for our customers in order to make their lives easier, and this is like one of them.
And then payload sizes also. It was really interesting for me because, I mean, this shows like the same like P50 to P99 payload sizes, but our data is separated between US and EU. So we couldn't kind of just like smush them together. But the difference, like, because we send a lot of webhooks for a decent amount of different users, and we still had a huge variation between US and EU, which means like there's like a couple customers here or there that are skewing some of the numbers. Yeah. But also when I looked at the implementations, I think the example I gave here was GitHub's payload limit is 25 megabytes. And in their docs, they talk about it as like, if you mess up this and this, you're going to go over the limit and we're not going to be able to deliver to you. So it's like something like they didn't just like arbitrarily set this 25 megabyte limit. It's like people are actually exceeding it. But then like PagerDuty's is like the limit is 55 kilobytes. So like my takeaway from this is like it's just going to really depend on the use case and what you're actually sending in the webhooks.
I mean, I think first of all, Americans like it big, right? Like big houses, big trucks, big everything. Yeah. So it's big payloads. But I think like when you look at this data, I mean, first of all, I think I don't remember our limit. I think our limit is like 350 kilobytes. Obviously, that skews the data a bit. We're not going to get like 25 megabyte payloads. We already encourage our customers to send less. But I think like even 50 kilobyte and like 7 are actually kind of the same ballpark in a way. It kind of like feels the same like amount of data. Yeah, it's like like 6x, 7x, but like it feels the same, right? But so when you told me, I remember actually when I saw the first draft of this report, and I gave you like feedback. I'm like, hey, you have a typo here. It can't be 25 megabytes. Like that doesn't make sense. Because the problem is like when you send webhooks this size, I mean, first of all, never mind the load on GitHub's systems. And maybe that's why, like GitHub webhooks are down as often as they are, but because it's just like, it's a lot of load on your system. It also is like terrible load for the consumer of the webhook because they need to accept, a massive payload. And they probably, like they're using like Python or JavaScript, wherever. So they kind of like, it automatically parses that into memory. So like into like a JSON structure. So not just like a string, it's like a JSON structure. And then also they need to kind of like look at the payload and see if it's something they care about and all of that. At 25 megs a pop, and it's actually like with the, there's going to be like overhead. So it's probably more like, let's say 50 megs a message. After 10 messages in parallel is already like 500 megabytes of RAM. And again, it's actually worse than that. But it just means that if you send like such big messages, you're essentially killing the consumer. You're essentially killing your own systems. It just doesn't make any sense. And also, like there's no way they're using all of this data, right? Like kind of like let them use let them look at the payload, look at what they care about, and then like make an API call to download that image or diff or whatever it is that you want to like include in the payload. It's just like so wasteful, sending like such massive payloads.
Mm-hmm. Yeah, that one surprised me as well. And like, I wrote it and I was like, that's interesting that it's so much, but like it didn't like, I didn't get like any visceral reaction to it. And then you like messaged me and I was like, I better go double check to make sure that I got it right. Yeah. So yeah, then I sent you the link to it. But yeah, I mean, but again, like I think it does some people's use cases, the payloads are really big and some are not. But I think like to your point, like if you have payloads of this size and that's what you're trying to send, maybe you need to kind of rethink a little bit about the scheme that you're using.
Let me give you actually two additional comments. I mean, first of all, you can see like PagerDuty. So PagerDuty is what I would call kind of like a tier one tech company in the sense that, or tech service in the sense that like they would never want to go down, right? They care a lot about like being up or like making sure that their systems are always operational. And I think like imposing that limit is their way of saying like, okay, this is a limit that we know that we can successfully, even like under crazy, like we can like handle at the scale that we handle things without adversely affecting our systems. And so I think that's that's a good signal to have. No, essentially, and the second thing is that you can like think of like webhooks in a way, kind of like email. You're not gonna like attach a 25 megabyte PDF to an email, right? You're gonna like include like a Google Drive link or like a Dropbox link or like any of those kind of things. Even like a lot of mail providers literally, I mean, first of all, a lot of like mail service literally like cap it at like 5 megs or 3 megs or whatever, and they'll just reject the email altogether. But even if they don't, they a lot of mail providers or mail clients automatically upload it to a service like Dropbox and then include the link rather than attaching it in the email, just because it's just bad etiquette. And yeah, I mean, it's the same with webhooks. Just like don't be an a-hole to your customers, essentially. Like send them like reasonable sized webhooks.
All right, and that is really the gist of the report. So again, like I'd mentioned the methodology earlier, but we also have kind of a list of the companies that we ended up looking at. And I think in the appendix, I also gave like a bunch of links to like some examples of good implementations and the actual original 100 API list that I took from someone's report of state of API developer portals is kind of where I got it. So this is like our first crack at this type of report. I'm foreseeing doing a 2024 version where we update some of the stuff we looked at, add some more stats like the suggestions that you gave, doing a little bit more correlation, and maybe we'll up the number of providers that we look at, things like that too. So
you know what, I would also be curious, and I know we've been collaborating with quite a few like really cool companies recently. We should probably ask them the same questions and see like what are their delivery stats, what are their like all the stats that we pulled out for Spix. Like I would be super curious to see like what they have to say about that. And but also I guess like how can people participate in like the 2024 version?
So right now, so first of all, with the 2023 version, you can find it on our blog. There's like a blog article that we link to the report. And for the 2024 version, what we're probably going to end up doing is trying to include more survey questions like that. So we'll have a form on the site soon, hopefully today, actually. It's like one of my top items after we record the video, to put a form up on the site that says, hey, like, would you be interested in us reaching out to you for the 2024 report?
Awesome. Yeah, cool. I mean, I guess they can also email us, like email or contact us on like the contact page or like Slack community.
More than happy to take any incoming requests as well.
No, man, I'm again, it's, when you first started working on this, I'm just like, okay, cool. It's going to be like, we know the lay of the land. It's going to be like what we already know, but it's nice to have it like in a nice format that like we can share with people. Yeah. But again, I love the fact that I was surprised. So that's an indication of like, of just like a good yeah, good like data sharing when it's kind of like when it's all obvious.
Yeah. All right. So yeah,
Cool. So
again, the report, if you want to read it, it's on our site on our blog. I think it just got the blog post is called State of Webhooks 2023. And again, yeah, we'll probably be coming out with 2024 next year. So if you're interested in taking the survey for us, would love to hear from you. Or if you have any suggestions of things that you want to see in the next report, happy to take those suggestions into consideration, and like as well, we'll try and add as much as we can.
So actually, a quick wager that maybe we can end with. Like, what do you think the numbers are going to be like in 2024 in terms of like webhook adoption, in terms of best practice adoption? Do you think they're going to be? I mean, we don't need absolute numbers, but do you think they're going to be 10% better, 20% better, 50% better?
I'm hoping. I mean, it's going to be different based on each best practice, right? Because they're at different levels. So like obviously, with the event types, they're already at 95%. They're not going to get that much better.
Yeah,
Um, and then the adoption rate. The other thing is like I'm still trying to figure out the methodology for the 2024 report. Like, do I look at the exact 100 same ones again? Do I add any? If I add a bunch more, it's going to skew a little bit, right? Because you're probably taking APIs that aren't as well implemented potentially. So I'm
yeah,
still like trying to figure that out. But I think if we were to just compare like the same 100, I would assume the adoption rate is going to go up. Some people are going to
yeah.
release webhooks that didn't, maybe up to like 90 or something. And then in terms of the best practices, I would hope to see the retries really go up.
Yeah.
Just because I feel like that helps the reliability of the system so much. I mean, we saw that the failure rates is 4.2%, but it goes down to 1.4% if you do retries, right? Like that's like a huge improvement, I think.
Yeah.
And when you have implemented this retry schedule, those 1.4% that failed, it wasn't really anything you could do as the provider, and like then you can go to the user and tell them, hey, like something is definitely broken on your end, you need to go fix it, right?
Yeah.
Um, so those are the two things that I would want. I just want more people to send webhooks and to do retries to make them more reliable. Those are like the two things that I'm most interested in. The other ones are really nice to have things. Like we talked a little bit about like the signature verification. I think the 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 best practices that were implemented at very low rates. I think you pointed this out is that it's kind of for. I mean, maybe not a good reason, but it's understandable why. It's kind of hard to do, like really hard to do. I mean, retries aren't like that easy either, but I think they provide so much value is why they were
Yeah.
implemented a bit more.
I think like what one interesting thing as well about this report is that I know it was changing live as you were doing this, because I know you've been like a nice, again, like a nice yeah, netizen, like a net citizen, and you're like reaching out to people like, hey, you should improve your webhook docs in
Yeah,
A B C ways. And actually, I think like we had actually ended up like collaborating quite a bit on like documentation, but based on really just like you reviewing so many documentation, so much documentation. So yeah,
yeah.
I mean,
Maybe I
it's
can
curious
put
like
my
how much you. Sorry,
I
go
can do
ahead.
that my outreach to these 100 people, 100 APIs that I analyzed.
Yeah, it's kind of like it's kind of like Schrodinger's cat. The moment you started measuring their documentation, they kept on improving. So like, there's
Yes,
no,
yeah.
yeah, there's no way of, yeah,
You just gotta take a snapshot at some point in time and just like present what you have. Yeah, but yeah,
yeah.
I'm expecting the numbers to be better. Um,
Okay,
I don't know when will we get to like 90% adoption of automatic retry? That I don't know. That would be nice if we get there. But
yeah. No, cool, man. Anyway, thank you for having me. This
yeah,
was a lot of fun. I'm like super excited for the report. So yeah, congrats.
yeah, all right. Again, everybody, if there's any stats that you would be interested in terms of webhook implementations, just like put them in the comments below, and we'll try them out to the next one. All right, thanks.
See you, man.